Welcome back, everybody. Are you guys ready for some fun? Who loves math? What makes math so much fun? It's not English is a great answer. What?
Challenge.
It's challenging. It's also used to solve real life shit. That's what we're gonna do. We're gonna work on some applications today. Unfortunately, applications in mathematics has another word. It's a devious word. They're called word problems. This shit pops up and you're like, fuck it. No one likes word problems. I actually think they're pretty good. I like them. They're harder to do. You have to do a lot of translating what it means. But they actually intend to solve real stuff. Before we do, let's talk about significant digits for a second. We're on applications of right triangles. Where does this shit come up? There we go, right triangle without drawing a triangle, a right triangle for the triangle. That's me being a pro right there. That's it right there. Maybe I better draw a right triangle. There we go, that's a right triangle. Alright, the first thing we want to talk about is significant digits. Ideally, you never have more significant digits than you started with. So significant digits is like count the number of digits after the first non-zero digit. If I have something like 1024. 1000.24, I should say. This has 6 digits. Zero point zero 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 24 as 2. There is some argument on zeros afterwards. Usually if it's a 0 at the end. Include it if you know it wasn't from rounding. For sure, it wasn't rounded. Like a decimal one is one of the trickiest ones. Usually on a decimal. Usually these get chopped off. when rounding. So their presence. Actually indicates accuracy. And should be included. Like if you were to write down a number, you wouldn't write down extra zeros at the end for no fucking reason. So their presence there usually means you like measured something and it had zeros at the end. And you know it had zeros at the end, you had a very good ruler or whatever you were using. You're doing a stopwatch and you've got thousands, hundreds, thousands of a second. I don't know how small a stopwatch goes nowadays. I know they get pretty fucking accurate. But if it's there, it means it was measured. Why do we talk about this? This usually matters, this matters after doing other operations. That's some weird examples, but I'm gonna go through them. Let's say we had 62 degrees, 36 minutes, and we round to the nearest degree. And then then we'll also let's look at converting to a decimal. And you know what? Let's make it 37 minutes. Make it 37 minutes. Because I think 36 minutes is gonna look too pretty when we do a decimal version. And defeats the point of using this as an example. How many digits does it have right now? 62 degrees, 37 minutes, how many digits does it have? That's 4, right? If we round to the nearest degree, what will we get? What? No. This is sneaky.
63, right?
And this one is 63.
That was 60.
You're used to thinking like halfway mark, like with money would be 50 cents. But on time, anything like, or in minutes, anything past 30 is past the halfway mark. So past the halfway mark here would be 63 degrees. How many digits do we have here?
2.
2. Which is fine. As long as we don't have more digits than we started with, we're good. What if I wrote it as a decimal? We've got 62 degrees plus 37 over 60 degrees. '62 plus 37 divided by 60. I'm gonna write down everything that my calculator shows. 6, 6, 6, 6, 6, 7, that's what my calculator shows. What should I actually write as my answer?
62.
Ignoring the nearest degree, but what do you mean?
Uh.
I wanna make. Like, just that? $62.62. We wanna do 4 digits. And that actually tells us, let's look over here to round. And so we'll have 62.62. That's the good answer. If we wanted to keep the same accuracy level. Keeps the same accuracy. So is it like a zero? When it ends after a decimal. Zeros at the end of decimals are good. If there are, wait, let's change that to say zeros. We don't like them at the end of whole numbers. If I tell you something costs $125,000. There's a really fucking good chance it didn't cost exactly $125,000. You know what I'm saying? When we get to like, especially the bigger that number gets. People start rounding off the shit that doesn't matter. And you maybe like, if this was like 501 or 400 or 900, it matters to you. But that's because anyone in this room. We're not fucking rich millionaires. If you've got enough where you can buy $1 million home without blinking a fucking eye. These zeros here at the end don't matter, you could, this very well could have been. 122,000 and they could be rounding to 125,000. We will assume that it's not, that they still stayed within the right thousands range, but it could have been. It could be 124,500, could be 124,900. But it could even be like 124,020. And someone just said, fuck it, I'm gonna round up. But we gotta go with what we see, we'll include the 125. Cause we'll assume they rounded appropriately, but this is unreliable. So we'll say 3. Oftentimes, there is an exception to this. If you see like 125,000. And maybe they put the money or the decimal. Then there's a good chance it's accurate. Including the decimal is usually done to. Indicate accuracy. Or not accuracy, but exactness, I'll say. Accuracy is when you're measuring, exactness is just there. Alright. Everyone have fun with that? move to the right. This fucking lens up here is blurry, and if I pop it out. In screen now. It's a little blurrier that way. Pop it out, it's actually less blurry. Alright. So. Let's put this to use in trigonometry, solving triangles. When we say solve a triangle. It means. Find the measure. Of all angles and sides. Throw up an example while you're writing and. Talk about it. Solve the right triangle. If A. Is 34 degrees, 30 minutes. And little c. Is 12.7 inches. And I'll draw a triangle. They will be. Let's see. So on triangles, we usually label the angles, get capital letters. I would mention this before, but I'm bringing it back up. Sides opposite, get lowercase. So big A, little a, big B, little b. C is really a pain in the ass, cause they look identical. You know what I mean? It's kind of like, you gotta look at. Oftentimes with C, you're looking at what the units are on it. You're not gonna have a side length C that has the degree symbol on it. You know what I mean? So showing units is kind of important. Show units. When you can. Or when you know them. Sometimes they put the angles on the outside, like such. So if I were to redraw this triangle with what I know. I know this is 34 degrees, 30 minutes. And I know this side over here is 12.7 inches. It's handy to go through and write a list of what you need to do. Write in the ones you know. And a pro tip that isn't really necessary to be exact. Is put a box around the ones where they're given information. Box the letters that are given information. And the reason why is in calculations. Use these if you can. The idea is we know that they were measured, they were given to us, so they're likely exact or accurate. Whereas anything we might do might have rounding, and rounding compounds. You may not think rounding compounds that much, but let's say if I was off by 0.1%. And I did the operation a bunch of times. Like if I had 100. And I multiplied it, if I multiply by 1.001, that's like being off by 0.1%. And it doesn't look like much there, but if I do it a bunch. All of a sudden, I'm nowhere near $100. 107 is still pretty close. 0.01 was a relatively small, or 0.1 error, 0.1% error. Is relatively small, but the error compounds. Pretty soon it's like off. If you were trying to hit something that was. I don't know, 100 yards away. With like an arrow. Or I don't know. You're throwing, maybe not 100 yards. This is about that's the number I use. If you're aiming for something and your accuracy is off. You can see like this is what happens with long distances, that accuracy. The further, the less accurate you are, like if there's an error in the angle, just by a little tiny bit. The distance is way off, same idea here. So use the original ones as often as you can. So at this point, we gotta go, well, how can we find, well, I can see from the picture, there's one other piece of information. That I know exactly what it is. The right angle. The right angle is definitely 90 degrees, they put the box there, it was sneaky. What do you think might be the easiest to find first? What? B. Big B. Why?
It's on the y-axis or,
That's not why.
Because it's gotta equal 180.
Cause we know how much the total angles have to equal, yeah. So like, finding big B is probably the easiest. We know that A plus B plus C equals 180. And we have 34 degrees, 30 minutes. Plus B plus 90. Equals 180. If I subtract the 90, it's okay, that's not bad. What is 34 degrees, 30 minutes in terms of decimals?
34.5.
34.5. I'm gonna write that for now. Cause I'm not a big fan of the minutes, I don't think you guys are either. Here I have subtracted 90 degrees from both sides. Go from that line to that line. And now here I'll subtract the 34.5 from both sides. And I get B equals. Is that 55.5? Looks like it. And I come here and say 55.5 degrees. I didn't round here, did I? Did I do any rounding? If I didn't do any rounding, this is a safe number to use also. I'm gonna put a box around it. No rounding. So big B is safe to use. Assuming I didn't fuck up. So maybe I'll make a circle around it. I'm still gonna put preference on the box letters that I started with. Cause there's a chance that I could have made it at error. Probably not, cause I'm guessing one of you would have said 90 minus 34.5 at this point is not 55.5. But in general, I don't have fucking an audience watching me while I work. So if I do something quickly, I might be inaccurate. Try to use the original information whenever you can. So now we gotta find little a and little b. Which is here and here.
I have a question, so how do you come out with 180 degrees?
A triangle adds up to 180 degrees, that's just fact.
Oh,
That's a given. That's something you just, it's like good as gold. Every triangle, regardless of the shape. That. They all have 180 degrees, if you add up the three angles on the inside. It's just a fact for every triangle. Alright, so we wanna find little a and little b. One of the angles that we were given A in the beginning, I'm gonna try to use big A. Find the other sides. And I think I'm gonna need to use little c too. But we'll find out when we look at what we have available to us. We have the trigonometric functions available to us. So we have all the 6 trig functions. And we have the good old a squared plus b squared equals c squared thing on right triangles. So let's say we want to start with little a. Which trig functions have little a if I'm using big A? Or what's the relationship of little a to big A? No. It's not the adjacent either, you're out of option here. It's the opposite. We look at the picture, it's opposite side of the angle. Adjacent means it's touching your angle. Adjacent means next to, that's like. I don't know if I looked up it in the dictionary, but I'm pretty sure. That's what it'll say, in as little words as possible next to. Little a is not next to it, 12.7 and little b are next to it. So opposite, which trig function has opposite in it? Cosine does not have opposite.
Sine.
Sine has opposite in it. So remember your SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent, so we have a couple of them. Couple of them that have opposite in them. If we look at sine. Opposite is the little a. If theta equals big A. Opposite is little a, and that's the other one that has little a, so sine or tangent are both good choices. Depending on if what we have for the third component. Hypotenuse is always the longest side, it's the side opposite the right triangle or the right angle. So C here is the hypotenuse. This one is 12.7 inches, this one is B. So at this point, the only one that I have full information on is this one. Because I can say theta or not apple, A, sine of A. Or sine of 34.5 degrees. Equals A over 12.7 inches. Guys with me? We can solve by for A by saying fuck fractions. So what we're gonna do is multiply both sides. By the 12.7 inches. And I will have 12.7 inches times sine of 34.5 degrees equals A. This actually has no units, so the only units that I have, those will be my units, inches. And now we're down to calculator work. I'm gonna write down all of the information and then we'll decide what we need to round to. How many digits should I end up with? 3. How do I know? That had 3. This had 3. Always pick the one that has the least amount. So we're gonna go with 3. And if I look to the number to the right. There's nothing else to add. We're not rounding up, we're rounding down, so I'm gonna go with 7.19 inches. I'll come up here and fill that in up here, watch this. I've got one left to find, right? B, little b. So little b, we know it's adjacent. Let me come up here and fill in these other ones. This would be little b over 12.7 inches. Or we have this one. So we have 2 choices for little b. One of these choices is drastically better than the other. Which one and why?
Back in here.
Tangent's a good choice. Well, no, but tangent, I guess we have 3 choices. Cause that one's in there too. It is not the Pythagorean theorem and is not tangent. Why do I not like those options?
Because they don't use a given number,
They don't use what?
the given numbers.
They don't use the given numbers, they use one that I calculated. They use little a. And little a, I rounded. So it's not accurate anymore. So like avoid using the ones that have any information you've calculated on your own, if you can. Sometimes you can't, sometimes you have to use something you've already used before. But in this case, cosine is actually the one that has all the information we had before. 34.5 degrees for the angle. And we have adjacent, which is the B we're looking for, over the hypotenuse. So A squared plus B squared equals C squared. And tangent theta equals A over B. Both use A, and we rounded on A. Which is bad. I'm glad you guys are all willing to answer whether you're wrong or right, it's fantastic. I very strongly approve, yeah. I did sine, I hope I didn't fuck it up, I did sine of 34.5 degrees. And I multiplied it by 12.7. And I made sure I'm in degree mode. When we get to chapter 6, we're gonna start doing radians, and there's a second mode in your calculator. And I may have to show you how to use it when you're doing it. On a test, please use a calculator, not your cell phone. I know cell phones have calculators, cell phones also have the fucking internet. And I'm not a moron. I may look stupid. I may sound stupid, I may act stupid, but I'm not. I will have my calculator with me if you need to borrow it on the test. But no cell phones on tests. So we'll do this one, same process that we did last time. We're gonna multiply both sides by that 12.7 inches. By doing that, it cancels out the thing on the right. And so we will get B equals 12.7 inches times cosine of 34.5 degrees. And then we'll do that on screen again. I did it all one step last time. I didn't show it to you, but you can. Times cosine of 34.5. And I'm getting, I'll write them all down. 10.466426. I'm really glad you guys are willing to answer questions, no fear of right or wrong. That's fantastic. That's how you learn. Make a mistake, you learn from it. And chances are, if you're willing to say it out loud, other people in the room thought it and just didn't say it out loud. So you answered their idea for them. Thank you for your service. Alright, so what should I put for B as my final answer on B?
1, 5, round up the 4, it's 3 digits.
So we're looking for those 3 digits again, right? We looked at the 6 says round it up, we're gonna go with 10.5 inches. That 0 in the middle counts, it's a usable digit. Alright, I'm gonna give you guys one to solve, I want you to. If you can, if you're willing to, work with the people around you. C is usually used for the right angle every time. A and B, depending on how you put them, as long as you label them in the triangle, you're good to go. That should be little a, not big A. Look at them fucking up in the book. And little c is 53.58 centimeters. No, but you can very well do A, B, C like this. C is almost always used for the right angle though. If there is a right angle, put it on C. Because then it lines up with A squared plus B squared equals C squared, you don't make mistakes. So either way you do it. Just changes where you start putting in signs and stuff. Where you start writing in the elements.
Or if it's the length of sides, not the angles.
Yeah, like, does it matter if I pass little egg on the bottom?
It has to be the opposite of the angle.
Okay.
I cannot put little a here opposite B because of it, if that's what you're asking, yeah. I didn't hear your question is so soft back there. You have something?
Never mind.
Good? Are you sure?
Yes, you said it's side of A.
Okay. So maybe I'll write that in, let's. Depending on how you write it, depending on where you put the big A and big B, that's what your triangle is gonna look like. Go ahead, take a few minutes and we'll solve it together,
That's a little C. Oh yeah, it's length.
yeah. Definitely talk to each other. Don't sit there and look at it blankly. Don't know what to do, talk to someone around you, and go, hey, how do you think we should start with this?
They know what's going on. I think so. Um. And if we go to the previous problem for cosine, where we plugged in the degree. To get to B, because of it being so cosine is adjacent over hypotenuse, right? So. We know that we have the adjacent, right, which is A little a, so that's 29. Over hypotenuse, we have C is 53. 5, 8. So we know cosine theta is that, right?
If you step, write down your trig functions. Write down that A squared plus B squared equals C squared and go, what elements do I have?
Or even do that, good point.
The angle, when you're choosing a trig function, which angle you're looking at matters. If you're going for angle A, it's you can use different ones than angle B. So make sure you know which angle you're trying to calculate when you try to calculate it. You guys stop talking to each other.
Walked in, dude, my friend just started working.
They both look like they're working out, maybe you give them enough. Maybe you spark the idea enough that they're starting. At least go, oh, maybe I should look at what I did before. Take a break to go to the bathroom, go for it. We'll work on this in like 10 minutes together. That way you got some break time in there. Well. Spiders, they get really loud, huh? You gotta be careful of them. Yeah. Okay. Couple nods. This is a hell of a lot harder if you haven't been doing your homework, isn't it? Like, I don't remember any of this shit, I haven't done my homework yet. Pro tip, do your fucking homework. Don't wait till the due date. That's a fool's game right there. Don't wait, you are playing the fool if you wait till the due date to do your homework. Cause that means, like especially in this class, you waited a fucking week since that lecture, and you don't remember a goddamn thing. Not a single thing. Maybe a single thing. It looks familiar. This shit's drastically harder. It's not easy as it is.
I'm trying to be caught up for each of these lectures. But I'm not caught up yet.
As long as you're doing what you can. If you're deliberately procrastinating till the homework due date, you are fucking yourself over. I give that extra time for people, like, you should do it like if you can the same day, you start working on it tonight, if you can. I give a week because we have people that work full-time jobs and are raising kids and shit like that. And sometimes the only time they have is fucking a couple hours a week to do that homework. So you put it off when you can, but like, just cause I give you a week doesn't mean you should wait a week. Don't treat it like taking out the fucking trash at home. Like, I don't wanna take it out yet. Don't wait till it stinks, take it out right away.
Do you recommend for us to do the homework before the lecture or after?
Oh, hell no, don't do it before, that's fucking hard too, that's even harder. This topic is much harder if you don't have like, at least, unless you're watching previous lectures or other stuff. This is really hard without that.
Yeah, that's what I'm trying to do, but, cause it's hard to learn just in this hour and a half or whatever.
Right. Very much is. That's also why I record them and post the videos, just in case you need to look back at it later and stuff like that. That doesn't, you still don't wanna wait till the last day. That takes adulting time, adulting experience to fucking figure that out for most people. Or like I said, some people just don't have the time, you do it when you can. There's someone in, I think she's in my online stats class, I was reading her introduction. She works 16-hour shifts or 16 hours like a day. She got 3 kids, she's married or she's got a husband. But she's got 3 kids, fucking works 16 hours a day, I'm assuming 2 full-time jobs. Didn't say how many hours a week. But I like, see, that's like, she's like, I don't have hobbies. I don't have time for fucking hobbies. My hobby is finding the luxury to go to sleep and get some homework done. That's why I give the extra time. Alright, anyone got an idea with what I should start with? I'll let anybody pick the first letter.
Sin,
What?
sin. Right, cause you already have the numbers, you already have A, C.
So find the other side? I didn't hear what you said. Find what?
So I'm just saying you already have signs, so you start with that.
What do you mean sign? Sign of what?
You already have, so we're good sign of A, right?
Okay, then, okay. You didn't say that, you just said sign. So sign of A. Sign of A would be opposite over hypotenuse. And that would be that and that, we do have those, that's a good choice. So 29 point, oops, that's not a 29, that's a 29. 29.43 centimeters over 53.58 centimeters. You'll notice that the centimeters cancel each other out, and we know we're gonna end up with degrees. And this looks like we have to do that sine inverse, Jess. It's sine inverse and I'm gonna do parentheses. 29.43 divided by 53.58. And I'm getting 33 point 163222393 degrees. What should I give as my answer for A?
Three point oh two. 3.16, right?
I hear 33.2 and 33.16.
Since, yeah.
You're changing your answer?
3.16.
Sure? Why?
Does
I really like 33.2, that's less writing. Are you confident with 33.16?
we can go to, yeah, and then just drop one number. So
33.16 is the right answer, don't listen to me, I'm fucking with you. 33.16, and we have four digits on each of these. So we wanna keep 4. So we'll go with 33.16. This is me testing you, you're just saying, let's go with that because someone else said it. Or if you liked it for a reason.
3 numbers, that's fine.
Alright, what should I go for now and how should I go for it?
Well, you gotta find B, so you can plug in the other ones, so you.
They're both B, which B?
Or little B.
Little B.
Sorry, little B.
We actually don't need little b to find big B. But if you wanna go for little b next, that's fine, how should I do it?
A squared plus B squared, C squared.
Yeah,
Easy.
we have the A and we have the little a, we have little c, let's use them. So we've got 29.43 centimeters squared. Plus B squared equals 53.58 centimeters squared. Ugh. Fucking decimals, who does problems like these, Mr. Jones? Why are you such an asshole? Don't round here. Don't round yet. Only round at the end. If you round now, you're gonna have it, it's gonna be off. I can subtract the 866 over. And I know, it's fucking tedious to write down all these decimal places right now. But if I start rounding early, that shit gets wrong. It gets wrong real fast. I've already had a couple chances I could have rounded, and if I round here, that's another rounding error. And get B alone by taking the square root. Normally, when we do a square root, we get plus or minus. What should I use here?
Positive, just a length.
It's a length, so we should use positive for sure. So I'll get square root of that answer. And now I'm getting B equals 44.77378.139 centimeters. Square root of centimeter squared is centimeters, which is good. That's what we wanted that. And so what's gonna be my final answer on B? 44.77 centimeters. That's good.
Large A.
Did I get a wrong thing for large A?
I got.
Yeah, I also got that. Yeah, I got that.
I got what you got.
Well, all right, let's try it again. Shit. Oops.
Oh, yeah, this sign was set up incorrectly, I think.
I fucking typed something wrong earlier. I'm getting the different answer now too. Ugh. Thank you. That was gonna be wrong, and that's why you don't use that letter later on. Cause it may look right. But if you fuck up the key, like calculation. So here we would have gone with 4 digits there. And we would have went with 33.32 degrees. That's good, cause I was gonna tell you when we do big B, don't use the triangle thing. Because if there's an error in A. And I didn't know it, there was an error, that was not planned, every once in a while, I'll do a planned error. Just to throw shit off. That was not planned, that was just fucking me, I don't know, fat fingering the keyboard or something. But we didn't use that for little b, so I feel okay with little b. And other people got 33.32. I wonder what it was my problem that I did it all at once? I thought I did that right. Nope, I fucking got 33.31 again. I don't know, I must have miskeyed something earlier. Alright, now to find big B. Don't use. Big A. You might have made a mistake, as you just saw I did, it happens and you won't know it. Unless you do the calculations a couple times, even then, you might have fucked up the calculations several times in a row wrong. So if I don't wanna use big A, what can I do with my triangle to find big B? It's a cosine, right? For big B. Cosine has adjacent and hypotenuse, and that happens to be A over C. So big B will be cosine inverse of those. Anybody else get that? Yeah,
I just don't understand, I may have missed it, but why are we using inverse?
cause if I don't. I'm not actually finding B, I'm finding cosine of B.
Oh, I see.
We want B by itself, we don't want cosine of B, we want B by itself. So like cosine, take cosine inverse of both sides. These cancel out as inverse functions do.
Wondering that same thing.
Good, I'm glad you asked. For functions like f inverse of x is the inverse of f of x. If you put f inverse inside of f. Or you put f inside of f inverse. You get the argument inside for both on either of them, they're both x. So in this case, it's b. I wouldn't have an x, I would have had big B there. That's something from algebra or math 35, you calc A. And it's been a while, it may have been a really long while, depending on when you took it or if it was high school or something. Good question. And I got that should be in degrees. What's my final answer on that one?
6.68.
56.68. Now, it looks like if I had done A plus B plus C, I would have gotten that answer anyways. But I wouldn't have gotten that answer if I had used my wrong answer from the first First try.
Yeah, I did it, and it was right, so.
So I would have gotten a couple answers wrong on the test, rather than just one answer wrong on the test. That's why you avoid using shit you've done as much as possible. Cause any mistake, no matter how small, trickles down. Alright, you guys ready for more? Well, fall asleep on me, man. I can bring a squirt bottle, it will help. I had a class one semester. It was down the hall, the classroom right at the end of the hall. And it's a fucking long classroom, for some reason it feels like it's way longer than this classroom. But there it is. I would keep the lights dim in the front, most people liked it, Gerardo, I had it on this way, but Gerardo turned these lights back on. It usually makes it easier for the people in the back to see. I had it dim, one person kept falling asleep. Like on the side of the room, like against the wall. And people across the room would stand up and point and snitch, and someone brought a fucking squirt bottle so that I could. Like. Shoot them with water. I was like, well, you guys are fucked up. They were doing that on their own years, I'm like, god damn. Good times, it's been fucking fun. Alright, let's up our game here. A couple of new ideas are the angle of elevation. Helps if I spell elevation correctly. If I'm standing here. And maybe I should say like my camera is on the ground, that's my camera. It's a shitty looking camera, get over it. Let's say I'm taking a picture of a building. And I want the camera to have just the top of the building. This angle here is called the angle of elevation. Theta is the angle of elevation. I could flip this around and say. Wait a second, there's a camera at the top of the building too. There's a camera at the top of the building filming the dude filming them. So what I'm gonna do is I'm gonna like make this horizontal straight line here. And this one, I'll use a different character, we'll use psi, that's a Greek character, psi. Psi here is called the angle of depression. Now, in this picture, they should be the same, but in general, they're not. It has to do with geometry and stuff like that, but. If it gives you an angle of depression, don't always just assume it's the angle of elevation. So depression is looking down from the horizontal, and elevation is looking up from the horizontal. So we'll use that, we'll use it right now. Pro tips in doing some of these word problems. Cause we didn't do a word problem yet, you just were given the triangle. Sketch it. Label it with what you know. Or can safely assume. There's very little we can safely assume, but I'll talk about that when we get to it. Use the sketch. To determine any appropriate equations to use. Then solve the equation or equations. And check to see if the answers are reasonable. Sometimes you'll be like, there's no way that's fucking reasonable. Like if we had information and we're like 50 feet away from a building. And we can see the top, and it's just like a short angle up, we know the angle. If all of a sudden you said the building was 2,000 fucking feet tall. Well, you can't see the fucking top of the building from 50 feet away, it's 2,000 feet tall. That angle would be almost straight up, you would know, like it shouldn't make sense. You'll see when we do go through some examples. And since it's a word problem, I'm not gonna try to fit it in on that page, but I'm gonna give myself some room to write. At a point A. That is 123 feet. Away from the base. Of a flagpole. The angle of elevation to the top. Is 26 degrees 40 minutes. Find the height of the flagpole. They do this shit. You've seen them on the road, maybe not with going for a flagpole. They'll have a little fucking. Thing on the road and they got a little like camera thing and they're like, they go away a certain distance. And they're measuring information, they're trying to figure out like the angles of elevation and shit like that. They do also like distance and all sorts of different stuff. It says we got a flagpole, I'm gonna make a little flagpole. Pick our flag. Quick little sketch of our flag. And it says there is a point A distance away from the base, so it's along the ground. And it says that this distance here is 123 feet. And the angle of elevation to the top. Is 26 degrees 40 minutes. That is, everything in blue is info I know. Red is gonna be something I can safely assume. Have you ever seen a flagpole that isn't straight? No, so I'm going to assume the flagpole is straight. That's important. Now we know we have a triangle, we can make a triangle. How often do you see a flagpole that's put in crooked? Like the Leaning Tower of Pisa? You ever really see that? No, so I think we can assume this is straight. And I think we can assume that it makes a right angle with the ground. Like you don't see like the fact, you don't see it like a flagpole like that. With the ground, it's always vertical, right? I think those are safe assumptions. What am I trying to find here? The height of the flagpole, so. I'm gonna put in H. Green is gonna be on my picture of what I want. Well, that's my color guide here. So I have angle A. I have the adjacent side. And I want opposite side. Does that look like a fair assessment? What trig function or equation has angle A opposite and adjacent?
Yeah.
Tangent. So I'm gonna write tangent A equals opposite over adjacent. And then fill in what I know. 26 degrees, 40 minutes. Equals H is what I'm looking for. Over 123 feet, how much is that? So if I multiply both sides by 123. I will get 123 feet times. Tangent of 26 degrees, 40 minutes. I'm gonna write it like this because I don't know how to enter 40 minutes in my calculator. I know there's a degree minute. Second thing on my calculator, but I never learned how to use it. It seems like a pain in the ass to me. But 40 minute, yeah,
Type in. Like, and it's 26 plus, and then parentheses 40, which is.
as long as if your calculator has percents or parentheses, yes. In fact, mine does, and I will walk through that right now. Times tangent. And I'm gonna say percent, not percent, with parentheses. 26 plus 40 divided by 60. End parentheses. If your calculator doesn't have it, you're gonna kind of want to do the operation on the inside first. When I do it, I get an overall answer of. H equals 61.77292175. That's what my calculator says. What should I get for my answer?
61.77. No.
I've heard
Three digits.
61.77, I've heard 61.8. Who likes the 77? Who likes the 8? I like the 8 too. Anybody got a reason why 61.8 is better than 61.77?
Around up.
Well, we would have to round either way, but why why round up to 8 rather than rounding to 77?
This distance so far has been 3 digits.
Yeah, not just necessarily distance, but the smallest number of significant digits was the 3 digits. That's what we want to stick our accuracy to. I will assume that's 4, this was 3, we're gonna keep with 3. So we're gonna say 61.8.
How'd you plug the minutes into the calculator?
I did 40 divided by 60,
Okay,
like. Maybe I may be able to move my,
It's like 0.666 repeating.
yeah. So if you don't have the parentheses thing, you can do this. 26 plus 40 divided by 60. And now most calculators have this little answer key of somewhere on it. I could say 123 times tangent of answer. And that'll also give me the same value. So 61.8, are we good? Is everyone happy with it? Everyone understood the problem so far? There's no complaints? Not right. Why is that not right? Why do I think that's not right?
Should say B.
Should say
Right, you
feet.
did, okay.
You gotta have the units. 61.8 was not enough. You need to have the units. Units matter. I don't know if you've ever heard how, I don't remember which mission it was. NASA worked with the international, or the, International Space, the European Space Agency or something like that. We work in, of course, our American units, and they work in their metric system. And we were planning ship to, for our mission to Mars, and no one checked units. Anywhere along the way. So they were using different units, and so when they spent all those millions of dollars developing it, launching it into space, sending it to Mars. So happy, so excited it gets there, and it's not going fast enough to go into orbit. So it gets pulled into the gravity well of Mars and just fucking lawn darts, fucking hits the surface of the planet, blows up. Millions and millions of dollars wasted simply because they didn't fucking talk about units. That's an extreme example of how units matter, but it's a fucking expensive lesson that mankind has learned. Alright. Well, let's say I am on the top of a cliff. Maybe that's not me. That feels weird calling me David. David is on the top of a 210-foot cliff. Looking down at a lighthouse. Or, yeah, looking down at a lighthouse. That is 430 feet offshore. It's not a little fucking slab of rock, they do this with lighthouses. Find the angle of depression.
That question is the same name, but
Yeah. From the top of the cliff. To the base of the lighthouse. No, when I'm in a problem, I'm gonna say Hefe. And I have a one I always like using in class, something like a test. You guys tie up Hefe and launch him as a human cannonball. Students always have a little bit of fun with that problem. So. I don't know if the lighthouse is the scale. A 210 foot tall lighthouse seems pretty tall. So maybe the lighthouse should be shorter, but it doesn't actually say what the lighthouse's height is. My given information is. This distance right here is 210 feet. This distance right here is 430 feet. And what am I trying to find? I'm actually looking for that angle right there. You know what, I'm gonna deliberately draw that lighthouse smaller. Let's deliberately draw it small. Because I don't want you to think that the lighthouse has anything to do with this picture. It's just the target where we're aiming at. That's fine given information. What can I assume? This right here is. That seems like a good assumption, if we're just like making a straight line go upwards. I can safely assume that's 430 feet, it's the opposite sides of like a rectangle kind of thing, right? Anything else I can safely assume?
The other side is.
That seems like a good assumption too. I'm assuming that I kept a horizontal line here. And so like if I went straight out, like that's how angle of depression is measured. It should be 210 also, that seems like a reasonable assumption. We'll assume the base is right at ground level. Of sea level. So now if I make that triangle without all that mess in there. This is what I had. What looks good here? What can I use? What?
Okay.
What'd you say?
Sorry.
We could try to go for the Pythagorean theorem, that's gonna give us extra information. But you can do it, it's not wrong. We are looking at that angle, so. Where's the hypotenuse? I have three sides, which side is the hypotenuse? That's that one. So we want the trig function without hypotenuse, because we don't have that information. Tangent does sound like the right answer. And you'll find in a lot of these. Tangent usually is a go-to choice for a word problem. Because how often do you have the diagonal memorized? How often is that, but we're looking at the fucking flagpole 100 feet away and we know it's 50 feet tall. The only time we'd know the diagonal length to the top of the flagpole is if we calculated it. It's not like something you would know, generally. So we're gonna go with tangent, we're looking at tangent theta equals opposite, which is from our picture. Which number? It's the 210. Over the other one must be the 430. So just like we talked about before, if we do the tangent inverse. On both sides, it's gonna kind of like wipe out the tangent stuff on the left. And I deliberately didn't write phi here because they kind of cancel out. Tangent inverse. 210 divided by 430. That's what my calculator says. What answer do I wanna get?
Just 26.
Just 26.
Did you wanna put the 0.0 for accuracy, just 3 digits?
Can we do the 0.0? Do we want 26 or 26.0? Why?
There are digits after it and it shows accuracy.
How many significant digits did we start with? No. If it's a whole number, we generally don't count the zero at the end. It's a tricky one, oh, that tricky one. We really wanna go with the 26. 26.0 is gonna be the same damn value though, so. Like, you couldn't really fuck it up. And I'll be honest. That's the least of my worries on the test is how. If you're off by one digit on the significant digits, I'm not freaking out. Done all the trig work, that's something we can train you into getting better at. 26 degrees. Couple other things you need to know, and we don't have a lot of time to go through problems on it, but I will show you where you can see problems work out that I've done myself. Let's talk about bearing again. I've mentioned bearing a couple times. Bearing is the equivalent of like heading or direction. When only one angle is given. Or when only one piece of information is given. It means clockwise from due north. So if it says 26 degrees. We generally call north straight up. And we're rotating 26 degrees off of that. And it's in that direction. If it says 170 degrees. Still going off of true north. Getting to here would be 90. Going all the way around to the bottom would be 180. So it looks like we're going close to 180 and we're stopping, and that would be the direction of 170 degrees. And if they have something, I don't know, like 310. That's 90, that would be 180, this would be 270. It means going all the way around till we get to about 310. A little bit past. The 270, that's 310 degrees. Now, if it has more information. If it has. Two compass headings. It goes like this. If you see something like north 42 degrees east. Or we'll look at north 36 degrees west. You start off with your north heading on both. East is to the right. And west is to the left. South is bottom. So it means start north and go 42 degrees rotated towards the east. 42 degrees towards east. This is like north 36 degrees towards west. So we would go 36 degrees that way. Which seems a little bit easier. As long as you know, remember which direction is west and east. Most people are pretty good with north being up. 'Cause that's the way we tend to show the globe, at least in the northern hemisphere. I wonder, in like the southern continents, like Australia and shit. Do they show the globe with the South Pole on top? I wonder. Do they show the world entirely upside down? This kind of shit makes you wonder, cause that's kind of like up for them. Then we have two more options. We could have south. Let's go 37 degrees east. Or south. 52 degrees west. South is down here, we start at the south. And we rotate in the direction it says. 37 degrees towards the east. .52 degrees towards the west. They have one other equation in there, I think the homework might give you something on it, I'm definitely not testing on this last one, I'm about to show you guys. This last one's annoying as fuck. It's called the subtense bar. And surveyors use this, surveyors do this shit. So like they'll put the camera at a point P. They're looking for a distance to Q. They want to find this distance D here. And they can measure the angle. They can measure this full angle right here. As theta. And they can tell the height over here is B. Put the Q right here to represent Q. Which means like this half here is B over 2. This half here is B over 2. That's kind of like theta over 2, and that's kind of like theta over 2. You're assuming it's split down the middle. You can use triangle information on that to find the surveyor stuff. I'm not gonna have anything like that on the test, you might see something with bearings. I'm gonna have a video loaded up tonight. From a previous class, but you can actually see it right now. I'm only showing you this subtense bar, so if there's a homework problem on it, it gives you practice. And I'll show you where like. Should have access to the video already, but I'm gonna show a link to it and put it in our main module also. Just back in a second, I just wanna show it people real quick. Chapter 5 content called 2024. Applications with bearings, applications. These are like shorter stuff. I'll make copies of them and put them in the book. Okay? But I will put them up here in our spring 2025 info. So we're checking out to see how those problems are done, like you're doing the homework. Right?
I think this one's.
Have a good weekend, GTFO.